So math quiz number 7. Number 1. The balanced equation by inserting the correct coefficients in the lines provided. Now, lucky for you, they already give you one of them. They gave you a 6 right there, which kind of helps this process out. So if they didn't give you a 6, if you start with the N's, you've got one N and one N. If you go to the H's, you've got 3 H's and you've got 2 H's. Okay. Well, we know that's going to be an issue. But according to the rules that I taught you guys last year, if you saw a 2 and you saw a 3, what did you do? You put a 3 in front of the 2 and you put a 2 in front of a 2 in front of the 3 and a 3 in front of the 2. Well, if you notice, what did they not have in front of that 2? They got a 6, right? So what that means is if you would have done it that way, you would have noticed that something was wrong. It did not balance out properly. There was an odd and even number on both sides, and you couldn't do it. So what they did is they went back and they just doubled everything, okay? So now we've got 12 hydrogens on the right, so I need 12 hydrogens on the left. So how would I get that? I need a 4 right there, okay? Then that also changes what number? Nitrogen, so I need 4 nitrogens, okay? And then as far as oxygens, how many total oxygens do you have on the right side of the product side? 10. Well, how do you get 5? Excuse me, how do you get 10 out of 2? 5, okay? All right, so the way this points work is they get 1 point per correct coefficient. So if they've got a 4, a 5, and a 4, they get 3 points. A 4, a 5, and a 4, they get 3 points. Okay? Looking at the next one. I have to rewrite it. Okay? So we've got a 4, a 5, and what was it, a 4? Okay, then 6. According to the equation above, assume you have excess O2. If you see this word right here, are you excited? Why? You don't have to find the limiting reactant. You know what it is. If you are given, let me also make a point. What if this entire phrase or clause was completely left out and oxygen was never mentioned? You're still fine, right? Do they have to tell you something's in excess? No, if one of the compounds, one of the reactants is left out, assume that it is the excess reactant. They do not have to mention it, but it is nice for them to go ahead and blatantly tell you that it is. If you are given 17.60 grams of ammonia, how many moles of nitrogen monoxide would be generated? Show your work below. So hopefully this was a very simple question for you guys, because I feel like it was. Yes, sir. Yes, very good. You would, or it could have read, if you were given 17.60 grams of both ammonia and oxygen. Does that make sense? And sometimes they'll give you that, where they'll say the same amount for each one, or they have to give you 2 differing amounts for each one. Okay? It's just really just based on the question, the way they want to word it. But be careful of how you read it. Okay? Now, we're in grams, and we've got to go to, so I always, like I said, I like to always do this. So I know I've got 17.60 grams of that stuff, and I'm trying to go to moles of this stuff. So I know that's where I'm going and coming from. Got to get rid of grams first. I may have no clue where I'm going, but why do I know for a fact that is at least on the bottom? Got to get rid of it. I got to cancel it. Okay, what's on top has to go to the bottom. Now, before I can go from ammonia to nitrogen monoxide, what's got to be that middle ground step? Got to get my mole to mole. However, the problem is I'm not in moles yet. So can I go from grams of ammonia to moles of ammonia? Yes. Okay, we're good there. And I'm going to leave that alone for just a second. I'm going to keep going. I may not have a clue where I'm going, but I know one thing is true. What is one thing that I can do with that stuff? The moles got to go on bottom. So moles of NH3, that is a guaranteed fact. Doesn't matter where you're coming from, where you're going. That has to be true. Okay. Now, my next question is, can I go from moles of NH3 to moles of NO? Yes, very good. And this is the most important step. So we've got moles of NO. So now let's go back and let's plug everything in. Where does your mole to mole step come from? Coefficients. What's the great news about these coefficients? Mathematically, they cancel. So would you punch those numbers in your calculator? No, leave them alone. That's a wasted step. Okay. Now the next thing, all you have to do is come back in. You have 1 mole in 17.04 grams. All right. So here's your final answer. Remember, there's got to be 3 things. What's the first thing you have to have? Correct number of significant figures. How many pieces of data are given in the question? many pieces of data. One piece of data, that's it. So that's all. That's what you're going to have to go off. So how many sig figs? 4. What else? So the first thing sig figs. What's the second thing? The unit, and the last thing is the formula. Okay. So when you do 17.60 divided by 17.04 should be what? 1 point something. 033. Sorry, not grams. Moles of NO. So 1.033 moles of NO. Now, let me go ahead and give you some good news for the day. And I'm going to grade you just like this because this is how the AP exam also grades you. The way they grade significant figures is they do what is called plus or minus 1. Plus or minus 1. So what that means is this question was supposed to have how many significant figures? 4. What is plus 1 significant figure? 5. What is minus 1 significant figure? 3. So as long as you are within plus or minus 1, do you still get credit? Yes. So if you had written 1.03 and stopped, is that plus or minus 1? If you had written 1.033 and whatever the next digit was, you are still within plus or minus 1. So is that okay? I'm going to grade you like that. If you had written 1.0, you would have lost the significant figure point. Okay, so make sure you keep that in mind as we go through. But try to make it as accurate as possible. All right, we go with that? That's a great question. 1 point, actually, let's see. So 1, 2, 3, 4, 7 points. 1 point for the correct conversion. So from going from grams to moles, that's 1 point. From going from mole to mole, that's worth another point. 3 points if their numerical answer is correct. 1 point for the correct unit. Oh, that's garbage. This is the first time I've used some of these. They gave 1 point if your answer was circled. So if your answer was not circled, I guess that's what they're trying to get you to do. Make sure it says show all your work below and circle your final answer with units. I'm not going to do that. Just give them 2 points for the correct units. So it's 7 points total. 1 point if they've got the correct gram to mole. 1 point if they've got the correct mole to mole. 3 points if they've got the correct numerical value with significant figures, plus or minus 1. And then 2 points if they've got the unit and the formula. Sir. I'm going to be okay with that for now, but if you didn't, and this is for everyone to hear, what he was asking about was, does this right here matter? Absolutely, it matters. So when you're starting to write these stoichiometry problems, when you're stoiching, you have to include the formula within the dimensional analysis. Say that again? That's fine. I mean, continue doing it, but the very final answer won't. Yeah. Always include the formula. All right, so number 3. According to the equation above, if you're given 25 grams of O2, 50 grams of NH3, how many grams of water will be produced? And then it says if 8.5 grams of H2 is actually produced, what is the percent yield? All right, so here's the deal. They gave you 2 values for reactants. As soon as you see that, what land are you in? The land of limiting reactants, okay? So we've got 25.0 grams of O2, and we've got 50.0 grams of NH3. Now remember, what's that cheat for the limiting reactant? Moles over coefficient. What would have made this problem a lot easier? Well, that, or if they'd given it to you in moles, your workload would have been less. Either one of them would have been fine. I prefer moles. Go ahead and give me the moles, so I don't have to worry about this conversion. All right. So we know that there are 32.0 grams in O2 in every mole of O2, and we know that there are 17.04 grams of NH3 in every mole of NH3. All right, so help me out. Well, I got it right here. I'll just pull it over for you. Actually, they did it a little bit differently than I would have done it. So right, so what was your number of moles of oxygen? 0. What'd you say? 781 moles. And then what about your moles of ammonia? 2.93 moles. Now, what do we then do with these numbers? Okay, hold one more second. What am I dividing them by specifically? The coefficients. What's the coefficient for oxygen? 5, and for ammonia was 4. All right, go ahead, Mason. Yes. And it's kind of one of those things, once you get to this point, all right, I'm going to say this for my purpose. I'm going to say this for the purpose for me. If you're taking a test, do it all. But for worksheets, if you can look at that and say, I know exactly what it's going to be, keep rock and roll. Don't waste any more time. But on test days or exams, make sure you make it obvious. Does that kind of make sense? Okay, go ahead. No, but the step that it takes to find it another way is a little bit longer. All right, tell me your way. And if that's, and I'm all up for discussion of making it easy as possible. What's your way? You converted both of them to water. You do realize that converting both of them to water is 2 additional steps than this for both of them. If you like it that way, I am totally fine with that. What I'm trying to do is trying to eliminate steps which could potentially give you errors. Does that kind of make sense? So if that works for you, by all means do it. I'm not going to go that route because I know that it could lead to further issues. Okay? Go ahead. Madison. For what color? Masses? What color is different on theirs than it is up here? We're not worried about that. All we're looking for here is to find the limiting reactant. Tristan. Just let's answer the whole thing, and we'll go back and fix it if you have a question. So again, the whole purpose of doing this was to determine what specifically. We're trying to find the limiting reactant. Would you all agree that even without dividing that top 0.781 by 5 is going to make it less than the other? Would you agree with that? Yes, that's basic math. So this is my limiting reactant. Are we okay with that? So now what we've got to do is convert our limiting reactant to our desired amount. Now let me ask you something. Do I have to start with that 25 grams original? No, what can I use to make my math a little easier? Let's go ahead and start with the moles because we've already found the moles. There's no reason to not use those. All right, so I've got 0.781 moles of O2. So I've got moles of O2 on bottom. How do I know that that is a guaranteed fact? I've got to get rid of it. I may not have a clue where I'm going, but that's got to be true. So my question is, I'm trying to get to water. Can I get from moles of oxygen to something in water? Yes, what do I have to get it in? Moles, very good. So I've got moles of H2O. Why can I not stop there? What's the question say? Grams of H2, very good. And so I've got moles of H2O, and I'm going to grams of H2O. This is where it gets easy again. Where does your mole to mole come from? Coefficients, and what are the top to bottom ratio? 6 to 5. And then we've got the only mass that I've asked you guys to memorize is water. There it is. And this is an easy math. You've got 3 things to multiply and then divide it by 5. Or multiply it times the fifth, whatever you prefer to do. Okay. So, how many significant figures are in your data points that you've used thus far? Okay. Thus far, you've only used the significant figures of 3. So your answer is in 3, so what's the final answer? 16.9 grams of H2O. That is his answer. So far, Madison, did this clear anything up? Okay, so this is your mass of water. Now, let me ask you something. You just calculated this. In an experimental aspect of it, what is that amount considered? Very good. So if they did not write theoretical, please write the word theoretical for them on this. This is your theoretical. In theory, if I gave you this, that's the most you could possibly get. In theory. In theory. If the experiment is perfect. All right, so the next part of this question. All right, so this was answer to part 1. The next part is percent yield. And what is percent yield? Very good. I'm just going to be lazy and write A over T. What was your theoretical? Actually, it's A over T times 100, right? Let's not forget that. So we've got 16.9 grams. And then according to this question, how much was actually produced? 8.50. So 8.5, 8.50 grams. And so whenever you divide it and multiply it times 100, your percentage is going to be around somewhere around 50. What'd you get? Okay. 50.3%. And I always get this question. How do you deal with sig figs and percentages? Carry the same number of sig figs through. Does that make sense? So you had 3, keep decimal point and everything. So 50.3%. Say it again. No, remember that's plus or minus 1. Remember? Okay. All right, so how to grade this one? 1 point from going to grams to moles of oxygen. 1 point for grams to moles of ammonia. 1 point for just showing the limiting reactant or making it known what the limiting reactant was. That's 1 point. Okay. 5 points for this bottom purple setup and the correct numerical answer. 5 points for that. No, you do not have to write the word theoretical. No. 1 point for the percent yield setup and 1 point for the answer. I just need to see some sort of division. Yeah, you don't have to write A over T as long as there's some sort of plug and chug involved. If you just write 50.3, that you lose 1 point. Okay, Nicole? What other way? As long as all their numbers are right, give them full credit. What number did they miss? Take it away. Say that again. Yeah, that sounds right. So weird. Yeah, it's broken. Yes. I'm going to, yeah. I forgot to do it the past few days because everything's been so crazy. And once everything settles down, I'm going to. All right. So that should be a total of 20 points, correct? Yes, ma'am. Yes. All right. One more time. Can I circle them in? I'm going to circle this. So this is worth a point. Actually, let's include that. That's worth 1. That is worth 1. Labeling the LR is worth 1. This entire thing, the correct setup, the correct answer, units, and everything is worth 5. Showing some sort of percent yield calculation is 1, and then the answer is 1. Okay. All right, put something out of 20. How many ever points they earned out of 20? and then pass it back to them.